There are two different kinds of table in Hive. Okay, so one being the internal table, and the other one is called the external tables. So when I was talking about taking the complete ownership of the metadata as well as the data in Hive, so that's where we can control this thing, whether to make Hive to take the complete ownership of the data as well as the metadata or not. So that's where the discrepancies come in, and that's where these two sort of tables are coming into play, the internal and the external tables. In the internal tables, also known as the managed tables, these are maintained by Hive itself, and the data is stored in the Hive warehouse. So where is Hive warehouse? So there is separate directory in Hive that is under users Hive warehouse, and there would be the DB name, then the table name. So under this path, your data will be stored. I mean, whatever you're trying to put as an internal table, so that data will be put into over this path. And also you have to, whatever data that is there in the Hadoop, so you have to load the data into the table name, whatever table you create in the name of internal table. So you have to load that data from Hadoop to that warehouse path, even though that warehouse path is also in the Hadoop. But the fact of the matter is, Hive takes the complete ownership of that path, or of that warehouse, so to speak. Okay. So internal table is by default. So whenever you create a table without giving any sort of location or without putting a keyword called external, then by default it will be the internal table. Whenever suppose you're submitting a Spark job and you just put it save as table, in that case also it will be stored into an internal table. It will try to create the table automatically if not created, and then it will put the table labeled as internal. So for internal table, there's one catch, is that suppose if you drop the table, in that case, if you run a drop table statement, in that case, it will not only drop the table metadata, but it will also drop the data as well. I mean, it will delete the data from that path. So there is this catch with the internal data. Whereas in external data, the Hive won't have the complete ownership of the data. So Hive will only store the metadata information, but the actual data will be residing in either Hadoop or S3, whatever file storage that you're using. So even if you drop that table, in that case, the data will still be intact into the data lake, whether be it like Hadoop path or be it the S3 path. So that is the speciality of external table. That's why in most of the cases, in most of the projects, real-time projects, external tables are used because we cannot afford to lose the data in some simple accident, right? So this is one key feature of the different kinds of tables, and making sure that if you're trying to create a table as external, in that case, you have to put that keyword create external table. Also, you have to put the location where the data is resided, be it the Hadoop path or the S3 path. So this is the fundamental difference between the internal and external table, and that's how Hive stores the data in between the two. Okay, now this is the most valuable part of Hive. This is actually where the significance of Hive comes in. So there are two properties. One being widely used is the partition and the bucketing strategy. So these two properties, in a way, helps Hive to manage the data in a more efficient way, and also at the time of querying the data, at the time of retrieving the data, it becomes much faster for the Hive client or anyone who's just trying to read the data from Hive or even write the data. Okay, so what is partitioning and what is bucketing, by the way? So let's talk about partitioning. In the world of big data, obviously, if I try to scan a file, a huge file, be it like in the GB or TB or XB, I mean the exabyte, in that case, scanning the whole record and then just retrieving one portion of it, that sounds a bit tedious, isn't it? Because suppose I have a table that is huge in terabyte and I want to read only say suppose 100 rows out of it based upon some criteria, based upon some where clause. But at the end of the day, when I try to run that query, it will try to scan the whole data, it will try to read the whole file, and then it will try to get that piece of information that only I require. Okay, so that sounds kind of a tedious job. So that's where the partition comes into play. Partitioning will simply segment the data that you keep in Hadoop or Hive into different blocks. So in that case, whenever you're trying to retrieve a data from a particular partition, only that partition will be scanned, and rest of it will be simply neglected. Now, what does partitioning mean? Okay, so how do you do that? So basically, if I have a table, say suppose if I have different columns, and one of the columns being state, if I have say columns like county, then state, then pin code, then address and whatnot. In that case, if one of the column is state and I'm just using that column as the partition column, in that case, so suppose I want to read a particular state, be it like Alabama, Arizona. Okay, if you see in this picture, there are different state codes: AL for Alabama, AZ for Arizona, FL for Florida. So if I want to read only the data that is inside the Florida, so in that case I can only scan this one. Okay, the FL one. Okay, it won't have to, Hive won't have to necessarily scan the other states as well. Okay, so this is the magic of partition. So this is how basically Hive will reduce the query time by scanning only the portion of the data that is required to be retrieved. So in Hive table, when I'll get into the examples, I'll show you in Hive table. So we will be using one partition column by using the term partitioned by, and then we will be passing that column, and also we have to make sure that we won't be using that column while creating the column, while defining the values. I'll explain each and everything while I'll be creating the table in a live example. But for the moment, just know that that Hive will basically create this folder structure once you create a table based upon a partition column. So that column, so under the hood, it will create different partition folders, or it will create different directories in the Hive warehouse. Okay, and when you try to fire up a query, say select star from a table name where state equals to AL, or say state equals to FL, then under the hood, Hive will go into the warehouse. Hive will only get into this directory, that is state equals to FL, and then Hive will try to read the data from there only. Because at the end of the day, as I told you, as I have mentioned many times, that Hive will just imparting the schema on top of the actual data in Hadoop. So at the end of the day, data will simply be read from the Hadoop cluster, and this is the Hadoop path where it is trying to read the data from. But on the metadata level, yes, you will be putting where clause where state equals to FL, and that's how the query plan will be orchestrated to read from that partition only, or that directory only. So this is the significance of partitioning. It becomes much faster in order to read any file, or in order to only the required chunk. So in day-to-day project, what happens is that the daily ingestion happens, right? And we put the data into different date partitions. So the thing is, if today is new data coming in and being put into only today's partition using a date column, so in that case, and suppose my downstream team is trying to creating a reporting, trying to create a dashboard, or trying to create a report out of it, or whatever they want to do, using only today's data. In that case, they can just query the today's partition, or the partition column that is created by today only. Okay, so that's how basically the Hive partition works. It's very smooth, it's very efficient. I have seen in 99% cases in the big data projects, wherever the Hive is being used, the tables are partitioned in almost all of the cases. And to enable the dynamic partition, okay, so I have to use these two properties, that is the Hive exec dynamic partition true and exec dynamic partition mode equals to non-strict. So these two properties will set the tone that whenever a new data is being loaded, or whenever a new partition is being loaded on an already existing table, so partitions will be created. But mind that there is another way we have to update the metadata. So there is a particular query or command regarding that. So that will be shown in the Hive examples. Okay, for the moment, just keep that in mind that whenever a new partition is being added into, suppose a new directory is being tomorrow, there's a user Hive zip code state equals to say XY. Okay, so Hive won't immediately acknowledge that partition. If you try to read the data from XY, Hive won't be able to understand. Hive won't get that data. But after updating that metadata, or updating the metadata information of the table using a simple command, that is msc create table, then only Hive will acknowledge that partition. Then only Hive will be able to read that data from that new partition that just came in. Okay, so this is about Hive. The next thing is bucketing. Although bucketing is something that is rarely used, but just for the general information, you should know that bucketing is also another strategy to to mitigate the issues while or to mitigate the issues of shuffling or data moving across the nodes whenever we're trying to aggregate the data in a simple table. Okay, so how it works is basically, let me paint a picture over here. Okay, so suppose I have this table and I am say I want this table to be clustered into 3 buckets. Okay, at the time of creating a bucketed table, I have to mention how many buckets do I need, and obviously there would be a bucket column. Okay, the bucket column will be say something as column A, right? So this is the bucket column. So now I have 3 buckets, and what Hive will try to do is basically put this file segment into 3 different buckets based on the column A. So how do we do it? In case of partition, what would happen if there were like 4 partitions? So column A, one value, suppose column A has 3 values, X, Y, Z. So X will go into one partition, Y will go into another partition, Z will go into one partition. But in case of bucketing, what happens? So say column value has this value like 6, then 7, then 8. These are the column values. Okay, 9, 10. Now there is a formula. Okay, and the formula is the nth bucket where the particular data will go will be equal to column value, that is the column a value percentile, that is the remainder value, divided by the number of buckets. Okay, so how does it work? So how does it work? So look at this example. For this column value, first column value is 6, right? First column value is 6. Now this is one bucket. So what we'll do, it will be one column value is 6. So it will be 6 remainder of the number of buckets, that is 3, right? So basically 6, if I just take the remainder of 6 and 3, it will be 0. So suppose this is the 0th bucket, this is the first bucket, this is the second bucket. So this one will go into the 0th bucket. Okay. Now the second thing is, now suppose the second column value, that is the 7. So if I put 7 over here, so the remainder would be 1. Okay, remainder would be 1. Let me just bring in a notepad, probably it's easier. So for the first one is 6 percentile 3, that is going to 0th bucket. Then 7 percentile 3, the number of buckets, it will be first bucket. And then 8 percentile 3, it will go into the second bucket. Again, when I come to 9, if I do percentile 3 equals to 0th bucket, again same bucket. 10 accordingly will go into which bucket? One bucket, first bucket. So if you look over here, so similarly 6 will go into 0, 7 will go into this one, 8 will go into 2, then 9 again will go into this bucket, 10 again will go to this bucket, and so on. If there is a column value 11, in that case 11 will go into second bucket. Okay, so that's how basically it works. So that's how basically it works, that all the similar column value, all the similar value that is having the same remainder will go into the same bucket. Now how does it help in aggregation? Suppose I have another table. Okay, another table, this is T1, this is T2, and in the table 2 also there is the same column, or suppose another column, say column B. Okay, so column B also have the same values, and what I'm trying to do is that I'm trying to join the column A from T1 with the column B to T2. Okay, So now if I bucket this table with the similar strategy, in that case, suppose column B also have this value 6, 7, 8, 9, 10, which are belonging to table 2. Now I'm trying to join these two table based on column A and column B. So column B, when I try to bucket with the similar strategy, in that case for the column B, sixth value will be going again into zeroth, seventh for column B will be again into this one, eight will be again into this one, second bucket, nine again into zeroth bucket, and so on. So what's happening over there, if I look at the zeroth bucket, okay, let me put it over here. Okay, so now zeroth bucket has the column value A, that is the 6, along with the column value B from the table name, that is the 6. Okay, and same goes for the other one as well. For this bucket, for the first bucket, okay, column A value of the 7, column B value of the 7. So you can see that both the similar column values are residing into same bucket. Okay, from both the tables. And what's happening, so if I try to join these two, if I try to join column A from T1 and column B from T2, in that case column A6 will be joined with column B6 immediately because they are on the same bucket. So they are just co-located into the same block, so it's much easier for them to join, right? So that's how basically bucketing helps in aggregating the data, or should I say, making the joins much faster when we are just trying to divide them into same number of buckets using the same column values from both the tables. So this is how bucketing works, and this is the strategy of bucketing, of making an efficient aggregation of the data. Whereas for partition, the efficiency comes in when I'm trying to read the data for a different particular column value. Okay. So this is the overall idea of the partitioning bucketing, and that's Hive deals with it when it comes to query performance and everything.